Hello, my dears. Welcome to Fatih's Academy of Easy Learning. In this video, we are going to discuss about the refraction of light, which is in our 10th chapter physics part.
Can you see I have placed a pencil in a plain glass, and when we are adding the water into it, what happens? The pencil looks as if it is cut into two halves, isn't it? You can notice that the size of the pencil which is immersed in the water looks a little bit larger than actually it is. Is that right? Can you see? The pencil which is placed or immersed in the water looks a little bit larger than actually.
In this video, we are going to discuss about the reason why the pencil looks bent and why the pencil a little bit large in size inside the water. The phenomenon responsible for this is the refraction of light. Let us discuss about the refraction of light. The chapter is light reflection and refraction. An important phenomenon exhibited by the light is the refraction. Let us discuss what is refraction all about. Okay, for that you can have a container of water. Suppose a light ray is incident normal from the water to the air. What happened? The light ray passes without any deviation, isn't it? Now, it is not the case when the light rays are passed from one medium to another obliquely. For the case of oblique transformation or for the case of oblique incidence, what happens is that suppose this line is the normal, which is the perpendicular drawn to the surface of separation of these two media. You understand what is a normal is? We have water here, we have air. These are the two medias, and we have an imaginary separation here. This line is the perpendicular drawn to the separation of these two media. Okay. This is called what? This is the normal. Suppose we have an oblique incidence of light ray from water to air. This has to pass like this. But it is seen that when the light ray obliquely incident from one medium to another, its path is always deviated from its actual position. Okay, what happens is that when the light ray passes from one medium to another medium, the propagation of its path is changed. Okay, actually it has to move through this, but it is seen that the light ray passes like this. This phenomenon is called what? Refraction of light. This there are certain law regarding refraction. Let us discuss about that. Okay. As we have already discussed, what is the refraction? The refraction means when the light ray travels from one medium to another medium, the direction of its propagation changes in the second medium. This phenomenon is called what? Refraction. Now we are considering two media, medium 1 air and medium 2 water. Suppose a light ray is What is this? This is the normal of this surface. What happens when the when a light ray is incident? Which is this light ray? This is the incident light ray. When a light ray is incident on the medium of separation, then what happens? It get refracted to the water. Actually, this is refracted like this. Actually, it have to goes like this, but due to the property of light, the refraction, its direction of propagation changes. You can see a slight deviation here. Okay, then we have the angle of incidence as it is the angle made by the incident ray to the normal. What is the angle of incidence? Angle of incidence is represented by the letter small letter I, which is given by the angle between the incident ray and the normal. And we have the angle of refraction, which is what the angle made by the refracted ray to the normal. Okay, is it clear? We have the medium 1 air and medium 2 water. The light incident on the surface of separation, what happens? It will deviate to the second medium, which is water. Here we have the angle of incidence I as the angle made between the incident ray and the normal, and the angle of refraction R is the angle made by the refracted ray and the normal. Okay, now let us move on to the laws of refraction. Okay, you can see the incident ray, the refracted ray, and the normal all lies in the same plane. Uh, and one more thing, there is a connection between the angle of incidence and angle of refraction, which is represented by a law called Snell's law that has been discussed in our laws of refraction. As you already studied the laws of reflection, there are two laws for the refraction also. Let us discuss that. Okay. The following are the laws of refraction of light. Suppose the incident ray, the refracted ray, and the normal to the interface of two transparent media at the point of incidence all lie in the same plane. The ratio of sine of angle of incidence to the sine of angle of refraction is a constant for the light of a given color and for the given pair of media. This law is also known as Snell's law of refraction. If I is the angle of incidence and r is the angle of refraction, then sin I by sin r is equal to a constant. We have already discussed about it uh, previous and we have already discussed about it. Okay, I hope the laws of refraction is clear to you. This constant value is called the refractive index of the second medium with respect to the first. While we discussed about the laws of refraction, we had the second point as the ratio sin I by sin r is equal to a constant. That constant is the refractive index. The refractive index is the value for a particular medium which determines how much the light enters into that medium gets deviated. Okay, we can have the expression for refractive index as follows. Consider a ray of light traveling from one medium to another. Suppose a light ray is traveling from medium 1 to medium 2. That may be any medium, from air to water, from water to air, from glass to water, glass to air, or air to glass, glass to diamond, any medium. Let v1 be the speed of light in medium 1 and v2 be the speed of light in medium 2. Then we have the value, the quantity refractive index of medium 2 with respect to medium 1 is given by the ratio of the speed of light in medium 1 and the speed of light in medium 2. This is usually represented by the symbol N21. This can be expressed in an equation form as N21 is equal to speed of light in medium 1 divided by speed of light in medium 2. What is mean by N21? The refractive index of medium 2 with respect to medium 1 is given by the notation N21, which can be calculated as speed of light in medium 1 divided by speed of light in medium 2, that is V1 by V2. N21 is equal to V1 by V2. Now the refractive index of medium 1 with respect to medium 2 is represented as N12. What is that? N12. What is N12? N12 is the speed of light in medium 2 divided by speed of light in medium 1, that is V2 by V1. Okay. If medium 1 is vacuum or air, then the refractive index of medium 2 is considered with respect to vacuum. This is called the absolute refractive index of the medium. It is simply represented as N2. What is meant by absolute refractive index? If the medium 1 is vacuum, if the light ray is propagating from air to any other media, then the refractive index is given by absolute refractive index. Next, we have to discuss about the optical density. What is meant by optical density? Optical density is not the same as mass density. We have two terms related to optical density as rarer medium and denser medium. What is mean by rarer medium and what is mean by denser medium? Let us see. It actually means optically rarer medium and optically denser medium respectively. When can we say that a medium is optically denser than the other? How can we say a medium is optically denser? Okay, while comparing the two media, suppose we have an air and water. When we are comparing, the one with larger refractive index is optically denser than the other. Okay, how can we say that a particular medium is denser or a particular medium is rare? Suppose if we have two medias, the light traveling from one medium to another. The one with more refractive index is optically denser and the one with less refractive index is optically rarer. Okay, now what is the importance of discussing this optical density is that there is something, there is some, what is the importance of discussing about the optically denser medium and optically rarer medium is that there is some, when a ray of light traveling from a rarer medium to a denser medium, the speed gets slows down and the light ray bends towards the normal. Okay, what happens when the light ray travels from a rarer medium to a denser medium? Suppose the light ray travels from air, which is rarer medium compared to water, a denser medium. What happens? Its speed gets slows down and the light ray bends towards the normal. So, same is the case when the light ray travels from water to glass. Here water is a rarer medium and glass is the denser medium. That when a light ray travels from water to glass, then also the speed of light slows down and the light ray bend towards the normal. Okay, now what happens when light ray travels from a denser medium to a rarer medium? Suppose when the light ray travels from water, which is a denser medium, to air, which is a rarer medium, what happens? The the propagation light gets speeds up and bends away from the normal. Okay, what happens when the light travels from a denser medium to a rarer medium? What happens? The light ray bends away from the normal and its speed get increased. Okay, we have the refractive index of value of air 1.003, water 1.33, rock salt 1.54, alcohol 1.36, kerosene 1.44, carbon 1.63, we have diamond 2.56 something. Okay, the refractive index of air, among which is the rarer medium, air, among water and alcohol, which is the rare medium, water. Comparing alcohol and kerosene, which is the rare medium, it is alcohol. Comparing kerosene and carbon, which is the denser medium, it is carbon. That is one with larger refractive index is more denser compared to the compared to the lesser refractive index one. Okay, kerosene and air. We know that the okay, in which kerosene and air, the kerosene have more optical density and air have less optical density. Hence, air is a rarer medium and kerosene is a denser medium. Okay, when in the case of water and kerosene, the normal density is more for water, but optical density is higher for what? Kerosene. But in normal case, kerosene have less density, less denser than water, but the optical density of kerosene is larger compared to water. Okay, we have discussed about what happens when the light rays travels from rarer medium to denser medium. Here, water is rarer compared to glass. What happens when the light rays travels from a rarer medium to denser medium? The speed gets slows down and the refracted ray bend towards the normal. Okay. Then what happens in the case of water to air? What is this case? Water is denser medium compared to air. Here water is the denser medium and air is the rarer medium. When it enters from a denser medium to rarer medium, the refracted ray deviates away from the normal. Okay, here what we have, the ray of light traveling from a rarer medium to a denser medium slows down and bends towards the normal. When it travels from a denser medium to a rarer medium, it speeds up and bends away from the normal. Water, a rarer medium, glass, denser medium, the refracted ray bends towards the normal. Suppose if we have, instead of water we have air here, and instead of glass we have water here, then also what, the refracted ray bends towards the normal. So, now we have glass instead of water and water instead of air, then also we have what, the refracted ray bends away from the normal. Okay, so you have all the portions, so we have discussed here is, hope all is clear to you. If you have any doubt, you can comment on the comment box. I will reply to your queries. Okay. Thank you. Thanks for watching my video. Keep updated with my channel so that you will have the all the